Okay, Assalamu alaikum once again. We are doing the the revision pack questions for Unit 7.3. So get your pen and paper ready. Let's go. Right, so conservation of momentum. What does that word even mean? It means that momentum before equals momentum after. Don't you forget it. So the system momentum, the momentum of the system before equals the momentum of the system after. That's all that means. Okay, after what? After collision, after change of direction, after change of velocity. That's what that means. Okay, so after being acted upon. Two ice skaters, question one says, two ice skaters stand at rest in the center of an ice rink. So we've seen this question so many times. We've got two people standing in the middle of an ice rink and they push each other apart. Okay, they push each other apart, and one of them goes that way, one of them goes that way. Okay, that's what's happening here. We've got 45 kilogram person going, so this person here is 45 kg. We don't know what this person is, so that's what we're trying to find out. The speed of the skater is this. What is the skater's mass? So 0.62 meters per second. This one is 0.89 meters per second. And they want to find out what this mass is. Now, before I even start doing the problem, I know that this mass is going to be less than this mass. The reason I know that is because the speed is higher. So obviously, if it's going at a higher speed, assuming that the force acting on it will be the same, then that means the mass is going to be lower. Something has to give. Remember, force equals mass times acceleration. That's what we are concerned with here. And we are concerned with Newton's laws as well. So for every action, there is an equal and opposite reaction. So in this question here, we are talking about a lot of physics, different concepts in physics. We're talking about Newton's third law of motion. We're talking about momentum conservation. We're talking about action and reaction forces. So what do we have? We have force equals mass times acceleration, which is Newton's laws. We also have momentum, which is P equals mv. So the momentum for this person is going to be equal to the momentum of this person. So P equals mass times velocity, which is equal to 45 multiplied by 0.62. In case you didn't know, by the way, I like talking in different accents, and that will just come out sometimes. I don't mean to do it, it just happens. So my apologies if you hear me talking in different accents as I'm doing these videos. It's not something I mean to do. It's just something that happens. 45 multiplied by 0.62 equals 27.9 kg dot meters per second. So that is, let me just get rid of all of this. And sorry about the sound in the background. That's just my daughter. That's 27.9 kilograms dot meters per second. That is going to be the momentum of this person. So that's going to be equal. Both momentums are going to be the same. Okay, both momentums are going to be the same. So now that I have the momentum, I can go back to this person here and go, hey, P equals mass times velocity. And now I know what P is. So I need to find out what M is because I already know what velocity is. They told me. So that divided by 0.89, and so the answer is going to be M for the person is going to be 31.3 kilograms. That is, that is how much this person is. 31.3 kilograms. Okay, I'm going to get rid of all of this mess now. Let's go to question 2. Two rollerbladers face each other. Once again, they're standing at rest in a flat parking lot. Tracy has a mass of 32. We'll give Tracy a skirt so we know she's a girl. Mass of 32 kilograms. And Jonas has a mass of, and Jonas, her brother, he is wearing Ijdasha. He has a mass of 45. Okay, and they push against each other. Jonas acquires a speed of 0.55 meters per second, and they want to know what is Tracy's speed. Once again, let's work with what we have. So P equals mv, which equals 45 multiplied by 0.55, and that equals 45 times 0.55, which equals 24.75 kg meters per second. And now that we have that, we bring it all the way over here, Shamsuddin, and we go 24.75. Remember, sorry, P equals mv. Always start with the formula. So we've got 24.75 equals 32 times v. So what does v equal? V is going to equal 24.75 divided by 32, which is equal to v equals 0.77 meters per second that way. That's all for that one. That's the answer. Okay, hopefully you got that one right as well. I'm going to pause the video for a second while I look at a message that I received on Teams. Okay, and let me just clear all of that. And let's go to question 3. An 85 kilogram lumberjack stands at one end of a 380 kilogram floating log. Okay, both the log and the lumberjack are at rest initially. The lumberjack then trots, that means walks a little quickly on the quick side towards the shore with a speed of 2.7 relative to the shore. What is the speed of the log relative to the shore? So easy peasy lemon squeezy. So that's him. His mass is 85 kilos. This is just going to act in the opposite way. Oh, this has a mass of 380 kilos. Yeah, I was just wondering if that was the mass. So the same exact situation, we got to work out the momentum of the lumberjack, which equals mass times velocity, which equals 85 multiplied by 2.7, and that equals 229.5 kg meters per second. So now we have the p value, and then we can go to the log and calculate that the momentum of the log, which is equal to that of the lumberjacks, is going to equal mass times velocity. So that is going to equal 229.5, 380 multiplied by the velocity, divided by 380. So the velocity, therefore, the velocity equals 0.6 meters per second. Okay, that's the velocity of the log. That's the first part of the question, I think. Okay, that's the first part of the question. That's part A. That's part A. Part B says, if the mass of the log were greater, would its speed relative to the shore be greater, less than, or the same as before? Of course, if the mass increases, then the speed would be less. It would be less than. The answer to that one is less than. That's the answer. And it says explain. Well, because look, momentum equals mass times velocity. So if we increase the mass, the velocity decreases. That's all. And let me just write that properly. Check your answer to B by calculating the speed relative to the shore for a 450 kilogram log. So if we replace this by 450, what will be the speed? It will be not 0.6, it will be 0.51 meters per second. So therefore, yes, it will decrease. Thank you. See you in the next one.